Assalamu alaikum. So let us continue the geography lesson number 2, lithosphere 2, exogenetic process. So last week we have seen the weathering and its different types. So this week we will start with gradation. Gradation is nothing but the leveling of land through some natural agents. Gradation takes place in two ways, degradation and aggradation. And gradation, it involves erosion, transportation and deposition. There are 5 agents of gradation, and in this class you will be learning about 3: running water, moving snow and sea waves. Let us begin with river.
The course of a river comprises of 3 distinct parts. First is the upper or the mountain course where the river originates. Here, the velocity of the water is faster due to the steep gradient. The floor of the valley is narrow and the valleys are V-shaped. Second is the middle or the valley course where floors are wider and the sides of the valley are more gently sloping. Here, the velocity of the river is slower than the upper stage. Meanders are typical landforms found in this stage of the river. The third part of the river is the lower course, which has a gentle slope and is almost flat. The river channel is usually at its widest and deepest here, because the amount of water flowing within the river is at its greatest. Oxbow lakes are conspicuous features in the lower course of a river apart from the deltas where the river drains into seas.
Rivers flow through hills and mountains at a great speed. Over the years, the rivers break the rocks on the mountainside. Huge stones break down and form soil while traveling with the water to the plains. Do you know what forms when a river falls over steep slopes in the hills? A river continues to grow bigger further in its course as other rivers join in. These other rivers are known as tributaries. Some tributaries join the river in the hills, while some join it later when the river reaches the plains.
Water in a river channel flows faster round the outside bend of a river due to centrifugal force, whereas it is relatively slow on the inside bends. The fast-flowing water on the outside bend erodes the river bank, whereas slow-moving water deposits sand and mud on the inside bend. In the lower course of a river, a meander becomes very much pronounced. The outside bend gets eroded rapidly and the meander loop becomes almost a complete circle. Gradually, the narrow necks of the loop erode further and intersect each other. Now, the river cuts through the intersection to flow in a straight path. As a result, the meander loop is abandoned and it forms an Oxbow Lake. The Oxbow Lake later turns into a swamp and subsequent floods may silt up the lake. It becomes marshy and eventually dries up.
In the plains, the river is heavy with the mud and sand that it has carried on its journey down the mountains and through the plains. Fine soil brought down the mountains by a river is called silt. During monsoons, water in a river fills beyond its capacity and it overflows its banks, causing floods. When the water dries up, the silt is left behind. Silt makes the land fertile, which is good for growing crops. The place where a river ends its journey is called the mouth of a river. From here, the river flows into a lake, sea or ocean. Some rivers carry a lot of silt up to their mouths. The mud makes it hard for the river to flow in one stream, so it breaks into many small rivers to reach the sea or ocean. Over the years, silt gets deposited between the smaller rivers in the mouth of a river. This forms a triangular shape known as a delta. Some rivers do not form a delta and flow into the sea in a continuous stream. The mouth of such a river is called an estuary.
I hope the video is clear to you and you have understood the landforms of river. Now we'll start with the next.
Landscapes formed by glacial erosion. Like water, ice can erode the landscape, and it does a fabulous job. Now, don't get me wrong, water does a truly fine job too, but if you want spectacular scenery, ask some ice to do its work. How does it work? Two processes, glacial abrasion and by plucking. Like water, it's capable of grinding away the rock that it travels over, but also it can pluck away pieces of rock and take it on their merry way. Let's start at the top. The top of the glacier is a circular area called a cirque. Another look at those cirques. As I said, they're circular areas located at the top of a glacier valley where the ice begins. Sometimes they'll have a cirque lake or a tarn in them. After the snow is all gone, that little depression is a great place to collect some water. Here we have some cirques. You can see how very steep they are. And here's a lovely cirque in the Sierras, one of the Kearsarge lakes. Notice the valley shape, totally different from a river valley. Here we have a very big U-shaped cross-section of the valley. Now, a glacial valley is easily distinguished from a river valley. If you saw a valley like that, you'd say, oh look, that must have been a young river that carved that valley. Or a valley like this, broad U-shaped valley, you'd say, oh look, that must have been an old river that laid down a floodplain and left us that valley. But if you saw a glacial valley, you would go, oh my, that is a valley. Look how steep the sides are. Look how deep it is. So here we have a nice, broad, U-shaped glacial valley. You can see they're mighty pretty. Here's another one. Here's a glacial valley, but it's hanging high above the main glacial trough. That's because tributary valleys like these deliver their ice to the top of the main glacier. They don't carve all the way down to meet the main glacial valley the way a river does. So here we have a tributary valley joining the main glacial valley. The main glacial valley is much deeper, so when the ice is gone, this tributary valley is hanging high above the original large glacier. That's what explains Bridalveil Falls in Yosemite. Here we have the U-shaped valley of the tributary glacier hanging above the much larger Yosemite Valley with a beautiful waterfall. This is Bridalveil Falls. Fjords. Fjords are long, skinny, narrow bays that were carved out by glaciers but have since been invaded by the ocean. Every one of these bays is now at sea level, but they were once filled with glaciers. Horns. When a mountain is surrounded by cirques, it ends up having very, very steep sides and can often be turned into a very distinctive, sharp-edged mountain called a horn. This is not just a horn, this is the Matterhorn. Of course, you may be a little more familiar with the Matterhorn you can find in Disneyland. Arêtes. Arêtes are very, very steep-sided ridges that are between glacial valleys. The glacier has eroded steeply on each side of it, leaving this sharp ridge behind. Those of you who know your French know that arête means stop, and certainly if you are hiking in this area, an arête would do an excellent job of stopping you.
Most deposits left behind by glaciers are composed of a generally unsorted mixture of clay, silt, sand, and boulders, known as glacial till. Moraines essentially define where the glacier paused, and the position of the moraine that is farthest down the valley, the terminal moraine, indicates how far the glacier extended during its history. Piles of unsorted glacial till can be trapped by an advancing glacier and shaped into oblong mounds known as drumlins. The sediment deposited within these subglacial streams leaves behind a skinny, sinuous landform.
Now you may be clear with the glacial topography. Let's see the third one, the work of waves.
Work of sea waves. Coastal landforms are caused by the erosion and deposition of sea waves. Sea waves continuously strike at the rocks. Hollow-like caves are formed on the rocks which are called sea caves. When the cavities become bigger, only the roof of the cave remains, forming sea arches. Due to the further erosion, the roof is broken and the walls remain. This wall-like feature is called stacks. The steep rocky coast vertically above sea water is called sea cliff. The sea water deposits sediments along the shore to form beaches.
What you have seen so far is the erosional landforms of waves. Now here is a video to understand depositional landforms of waves. A bar is an elongated deposit of sand or mud. A spit is a ridge of sediments attached to the land on one end. It terminates the open water on the other end. So I conclude here. Today you have learned 3 agents: river, glacier and waves. So inshallah in your next class you will be learning the other 2 agents. Get ready to complete your assignment and send me soon. Assalamu alaikum. Jazakallah khair.